Hi friends, welcome back to Edupedia world. Today we will discuss a new topic on sound, that will be vibrations of sound. We will specifically discuss three things. We'll discuss what is free vibration or natural vibration. We'll see what is damped vibration, and we'll conclude the lecture with forced vibration. So let us start with today's lecture. Imagine a body is clammed at one end and the other end is struck. For example, suppose there was a bar tightly fastened with the wall and this free end is struck by hand or hammer or something. Then this bar will start to vibrate. Okay, and these vibrations are known as free or natural vibration, because there is no restriction and no external force applied after striking. I mean, once it has been struck, it is free to vibrate on its own. Okay, and this vibration will have a particular amplitude, a particular time period, and these things, the frequency of vibration will depend basically on the size and shape of the body. Now, to define free vibration or natural vibration, the periodic vibrations of the body of constant amplitude in the absence of an external force. Okay, that is known as free vibration. So let me mention it in points. In absence of any external force, the body will continue to vibrate, will keep vibrating with same amplitude. This phenomena is called free vibration. Okay, so the body will keep on vibrating for infinitely long time until and unless some external force is applied. Now let us see some examples of free vibration. A point to note is that for the free vibration to take place, there should not be any external force. That means there should not be any damping force also. There should not be air resistance or something like that. So basically, free or natural vibration is possible in case of vacuum. Else there will be air resistance and the magnitude of the amplitude of vibration will keep on decreasing continuously. But let's assume that we are in vacuum condition. Then what will happen? An example for free vibration would be a pendulum hanging from a string. If we displace it slightly on either side, then it will keep on moving along this path for infinitely long time. So this is an example of free or natural vibration. Again, another example would be, suppose a mass is attached to a spring and this is the natural position, but suppose now we pull it somewhere and we bring the mass here, then the mass spring will try to pull it inside. As a result, it will start to vibrate, go inside, again the spring will push it and it will keep vibrating like this, given there is no air resistance and there is no friction on the surface. So these are kind of ideal situations which will never happen, but for the sake of argument, let's say this is an example when there is no air resistance and no frictional forces from the ground. Okay, now you have an idea about what free or natural vibration is. Let's discuss the nature of free or natural vibration. you might already have understood it from here, but still I will explicitly mention it. If you plot the displacement of the body against the time, so a plot of time versus displacement in the case of natural vibration will be something where the amplitude will not change. So a fixed amplitude, let's say this is plus A and this is minus A. This axis is time. So our vibration will be something like this. That is, the amplitude will not change, the frequency will not change. It will keep on vibrating as it started till infinity. Okay, now this, as we already discussed, this free or natural vibration is an idealized concept. We never in reality encounter it unless we have very good experimentally set up vacuum conditions. So what is the more common condition, or what is the more common kind of vibration that actually happens? That is known as damped vibration. Damped vibration. So now what is damped vibration? Damped vibration is the phenomena due to which the amplitude of vibration continuously keeps on dropping because there is always some external force present in form of air resistance or frictional forces from the surface. So let's define it. The periodic vibrations of a body of decreasing amplitude in presence of a resistive force. That is what is damped vibration. Now what would be the example of damped vibration? Quite easy. These two examples which we discussed here in real life scenario are actually damped vibration examples. Let me re-explain them. So we have a pendulum, and suppose we moved it till here and let it swing. So initially what will happen, it will swing like this, come over here, this will be the extreme in this direction, keep on swinging, but with each swing the amplitude, that is the final position of the bob, will keep on changing, and after some time what will happen is the vibration will stop and the pendulum will come and stop here. This is because of the air resistance. Similarly in this case, once we take it here and leave it, the spring will initially pull it this side, it will come till here, but with each journey, each oscillation, the distance moved by the box will keep on decreasing, and after a time finally it will come and settle down here. So here what is happening? Damping is happening because of the resistance. The amplitude of vibration is keeps on decreasing until it finally comes to its standstill. Right? So what will be the nature of the graph for this? The nature of the graph will be something like this. Let me show. This is the time axis, this is the amplitude axis. I will explain what I am drawing. So what will happen is that initially the amplitude will be large, but since there is air resistance and other forms of resistive forces, the amplitude will keep on decreasing and it will, after a certain number of oscillations, it will completely stop. So we see that the amplitude is continuously going down. This phenomena is called as the damped vibration. Okay, so you have an idea about free vibration, that is an idealized scenario, and also an idea about damped vibration. Is there something more? There is a scenario where you can apply external force to the body which will act against the resistive force such that the amplitude remains constant. So what I mean to say is there is always a resistive force, right? If you apply a force from your side exactly equal to the resistive force but in the direction opposite to the resistive force, then those two forces will cancel out. Okay, and it will appear to the body as if there is no resistance, and as a result the body will keep on vibrating like this scenario, that is the amplitude will not dampen, and such vibrations are called forced vibration. Let me write it here. Forced vibration. So how can I define forced vibration? Forced vibration are the vibration which takes place under influence of external periodic force, under influence of external force such that the body maintains its amplitude. Okay, and that is called as forced vibration. Now what can be few examples of forced vibration? Few examples of forced vibration would be like a guitar player playing a guitar. What happens? He forces the strings to vibrate by striking the strings, striking the chords of the guitar. Or the vibration produced by the diaphragm of a microphone, right? So these type of situations where an external force is being applied and that results in a vibration, production of vibration, is called as forced vibration. One point to note is that, as I mentioned, that the forced vibration can result in the amplitude remaining constant, this situation. But what if the external force applied is not the same as the resistive force? Obviously then the amplitude will not remain constant. The amplitude will be reducing continuously or increasing continuously depending on whether the resistive force is large or the external force we apply is large. But even that phenomena will be termed as forced vibration because we are actually applying external force to make the body vibrate. Okay, so this gives you an idea about the three major kind of vibrations that can take place. Let us see side by side the differences between free vibration and forced vibration that we have discussed. And these differences will also give you further insight into forced vibration, which might not have been clear from our discussion till now. So the first point of difference is the basic definition, that is free vibration takes place in the absence of a resistive force, right? But forced vibration takes place in presence of an external periodic force. So external periodic force is a must for forced vibration to take place. Second, the frequency of vibration for a free vibration is basically a function of the shape and the size of the body. So that kind of defines what will be the frequency of vibration. But in the case of forced vibration, the frequency is decided by what is the frequency of the external force. As we have said here, that the force is a periodic force, external force is a periodic force, so that periodicity will define the periodicity of the forced vibration too. So the frequency of the external force defines the forced vibrations frequency. Third, as we have seen that the frequency is a function of the shape and size of the body for a free vibration, therefore it ought to be a constant value. It is kind of a characteristic property of the body, the free vibration frequency. Whereas the forced vibration frequency is basically dependent on what is the frequency of the external periodic force. And finally, the amplitude for free vibration remains constant. That is also the defining nature of free vibration. But in the case of forced vibration, a very strange, a very important phenomena occurs. What happens is that the amplitude of forced vibration not only depends on the frequency of the body, yes, the frequency, but also the frequency of the applied force. So there are situations where the natural frequency of the body and the frequency of the applied force match, then a phenomena occurs which is called as resonance, and the amplitude really rises very high. So the amplitude in case of forced vibration depends on the frequency of the applied force too. And what is the frequency of the applied force compared to the natural frequency of the body. So this is an important phenomena which gives rise to the phenomena of resonance, and we will not discuss resonance in the lecture today, but we will discuss it in the next lecture, so that's there. I hope this discussion made much more sense now, and forced vibration is a clearer concept after hearing to this discussion and this comparison with free vibration. And with the hope that you will joining us in the next lecture, where I will be discussing about resonance and see how that works. Till then, have a great day. Goodbye.